Hello students, question number 16 is from test series 2, subject strength of materials and chapter thick and thin cylinders, and it is of 1 marks. The question says that a thin walled spherical football of wall thickness T and diameter D is filled with gas to a gauge pressure of P. The maximum shear stress on the outer surface will be option A PD by 4T, option B PD by 2T, option C 0 and option D PD by 8T. So we'll consider a spherical football of diameter D and thickness T filled with a gas of gauge pressure P. Now the pressure acting inside this football, will view this football as a thin cylinder filled with gas. So the pressure acting inside the cylinder will be P, and the stress due to this pressure will be sigma, which will act at the outer surface in the area of the thickness T. The corresponding areas for this is, it is A is pi by 4 d square, and for the outer surface the area will be pi dt. Now we will calculate the circumferential stress, which is the normal stress or hoop stress which acts at the outer surface of the cylinder. We will equate both the stresses, that is sigma into pi dt, the area, which will be equal to the pressure acting inside the cylinder, into the cross sectional area, which will be pi by 4 d square. From this we will get the equation for the hoop stress, which is sigma is equal to PD by 4T. Now we will view this formula in a 2D plane stress, which can be viewed as this. The forces or the stresses acting in the x direction will be PD by 4T, and the stresses acting in the y direction will be PD by 4T. Now we know that the shear stress will be half of the nominal stress. So we will find the maximum shear stress, that will be sigma max minus sigma minimum by 2. By substituting the values of maximum and the minimum nominal stresses, that is PD by 4T, we will get the maximum shear stress as 0. So the maximum shear stress on the outer surface of this thin walled spherical football is 0, and which is option C. Thank you.